Today we're looking at light and how it behaves and where it comes from. We're going to start with where light comes from. So up here at the top, we know that all of the light that we have on Earth comes from deep inside the sun. And what happens inside the sun is called nuclear fusion. And when you fuse something, that means you combine things. It's the opposite of nuclear fission, which is when you rip apart an atom, and we talked about that with the atom bombs. So inside the sun is actually nuclear fusion. We're not ripping apart an atom, we're actually smashing together two atoms. And the atoms that the sun is made up of is hydrogen. So here, capital H is for hydrogen. It's got one proton and one electron. So when two hydrogen atoms, they're flying around inside the sun, and whenever they smash into each other, they combine and form one heavier helium atom. And in that combination, when they form that helium atom, they also form a little bit of extra energy. So there's a little bit of a zing that comes out when this helium atom is made. And this particle of energy is called a photon. And it's part particle, part wave, and it's a light energy particle slash wave. And if you watched the video on Friday of last week, you saw how that works, how particles can sometimes act like a particle, like a baseball, or sometimes they act like a wave of energy, and a photon does just that. It's both. And inside of this photon are all the sections of the electromagnetic spectrum. So everything that we looked at last unit on the electromagnetic spectrum is all inside of this photon. And we just see this small section of visible light, which is what we're going to be focusing on, just that visible light section of the electromagnetic radiation. All right, so once that photon is formed, the helium stays in the sun, and this photon particle, it travels from the inside of the sun, it travels to the outside, and sometimes this can take hundreds of thousands of years for that one photon to finally reach the surface of the sun. And once it reaches the surface of the sun, it shoots out, and it takes 8.5 minutes at the speed of light, which is 186,000 miles per second, 8.5 minutes until it reaches our Earth. All right, now once it reaches our Earth and we're looking at it with our eyes, we know that the light waves will either be absorbed or transmitted. So I have an example here of an apple and an eyeball looking at an apple. And so these photons, these light particles, they hit the apple. So this is represented right here. The light particles hit the apple, and some of the light is absorbed into the apple, but the red light is what is bounced off. So we know that light has different wavelengths. We start on the red side with Roy G. Biv. Red light has the longest wavelengths, and violet light has the shortest wavelengths. So depending on the wavelength, it's either going to go into the apple and be absorbed, or it's going to bounce off of the apple. So here the red bounces off, and then it's absorbed by your eye. So the apple absorbs all light wavelengths except red, and the apple transmits or reflects back the red light wavelengths, which are absorbed by your eye. Okay, and all objects are either going to be opaque, translucent, or transparent. And this has to do with how the light interacts with the object. So an opaque object, no light waves can pass through this object. All of the light waves are either absorbed into the object or reflected out. They bounce off. So an example would be the apple that we looked at. So if you were standing on the other side of the apple, you wouldn't see any light that comes through. No light is going to pass through that apple. This would be a rock. Light doesn't pass through a rock. And another example would be a human. Light doesn't pass through us. The second way that light can interact with an object is if the object is translucent. So this allows some light waves to pass through, but some light waves are absorbed and some light waves are reflected. So some go through, some get absorbed in the object, and some bounce off. Examples of this is wax paper, colored glass, and sunglasses. And then we have transparent objects. This is where all of the light waves pass straight through. Nothing is absorbed by the object, and nothing is reflected off of the object. So this is going to be clear things that light just can pass right through. Clear glass like windows, your eyeglasses, or a prism. All right, the next thing that light does that we're going to talk about is called refraction. And this is when light passes through two different mediums. And we learned last unit that the medium is just the substance that the wave is traveling through. So the light wave is traveling through, let's say for instance, air. So you just have light waves that are traveling right through the air. And then maybe those light waves pass through some water. Now, water is denser than air. That means the particles are more close together. So it's going to actually change the speed that the light travels through that medium. And when the light waves change speed, they actually bend. So there's an example here that you guys have all seen this before. When you put a straw into a glass of water, the straw looks bent because the light waves slowed down when they hit the water. So the light waves are traveling at the speed of light here until they hit this water, and they slow down a little bit, which causes that light to bend. All right, one more thing we're going to look at is lenses and how light interacts with lenses. So there's two types of lenses that we're going to look at. One is concave and one is convex. So light, we know, travels in a straight line. Light travels in a straight line unless it interacts with another type of object. So here, a concave lens is a lens with a curved in surface. So the surface is curved inwards. And I always remember the difference because I think about a cave. Concave reminds me of like a bear cave, and you have to go in. So concave is a surface that's curved in. And what this does is it bends the light waves out and away. So the light waves hit this concave lens, pass through, and are separated and bent, and they go outward. And then another type of lens is called convex. So this type of lens has the lens with a curved out surface. So this time, the surface here and here is curved outward. So light's traveling in a straight line, hits this curved out lens, and what this does is it actually bends the light toward one focal point here. So this is kind of hard to read, but it says bends the light waves and focuses them at one point.